Hey y'all, hope everybody is having a good holiday. So, this past week I completed updating my Zigler package, which is a library that allows you to write inline Zig nifs for Elixir to 0.7.1. You can now get that version from hex.pm, and if you are using it, please do read the release notes and also read some of the guides because I updated the documentation. If you're relying on the syntax that I presented in one of the earlier videos, do read the guides because some of that has changed in the process of doing the release. All right, so now that I'm done with updating that, I'm going to go back towards working on Mavis and Selectrix, which are my experimentations in building a compile time static type checker for Elixir. So what I want to talk about in this video are examples from this wonderful blog post that the Erlang folks built called a brief beam primer. It discusses the process of how your Erlang code is turned into Beam opcode. So that's the machine language that the Beam virtual machine can read. They give an example where they create several functions and discuss how those functions are converted to opcodes and what they look like when they are. In particular, what I've done is I've written all of those Erlang functions into Elixir functions partially for the benefit of myself, and because that's what I need. I want to use these examples as kind of a first sanity check on my type checking system, and to also give kind of a focus point where everything has been really highly described and I don't need to do as much discovery to try and figure out what's going on. Now I've commented out some of the functions because I really want to laser focus on this first function called sumTail, which uses tail call recursion to calculate the sum of the items in a list. So this is the function. I'm not going to go too much into detail about it. And here is the disassembled code from the module primer examples. There's a lot of boilerplate in here. There's a function called double_info, which gets dropped in there. That is put in there courtesy of the Elixir compiler. The double_info function is actually kind of a way to figure out whether or not a module was created by Erlang or Elixir. But also it does provide information about the module itself. There is similarly a function called module_info. This function is put in by Erlang, so all Erlang modules will have this pair of functions, arity0 and arity1 in there. And yeah, so then there's this sumTail function, which is the meat of actually what we're looking at. Now, I'm not going to go through this line by line because that is done in the blog post. But what I do want to take a look at is this is nil opcode, or rather this test is nil opcode. Now, all the test opcodes basically do a binary comparison, and depending on the result of the binary comparison, if it fails, it jumps to a particular place in the machine code, and if it succeeds, it does something different, which is denoted here, or right. So in this case, if it fails, it jumps to the location label 10. And I won't get into too much detail about this, but effectively this is a failure code. Okay, so, but that's weird because nil is pretty much an Elixir only construct. It's an atom that is given a falsy result. So in Elixir, there's only two falsy values, nil and false. And in Erlang, I don't believe there is a concept of nil, and I don't believe that it is falsy. Moreover, it really doesn't show up in too many places. I think there's maybe only 2 or 3 places in Erlang and Erlang OTP where the nil atom is used for anything. So let's test this out. So kind of the working hypothesis then is that if I write a function f of, and it takes the parameter nil, or pattern matches against the parameter nil, then there will be an isNil operand inside of that, inside of the decompiled code. So let's do that. I'm going to start up a terminal session, and then we are going to, let's grab the code. So bin get object code playground. Okay, so that dumps the object code from the playground module, and then we need to disassemble it. And so to do that, we do beam.disasm. Oops, beam disasm file. Okay, so here is the opcode for that. Here are the opcodes for that. And all right, as before, we see this info function, which is the Elixir boilerplate, and we see the module info functions, which are the Erlang boilerplate. And here is our function f, and we get this is eq exact f atom nil. So not at all the opcode that we expected. So let's actually look at our primer examples and look at the sumTail function. And what's happening is it's in the arity2 sumTail that we see this isNil. So this is function sumTail2, and then we see isNil here. It's actually the second test. So the first test is whether or not it's a non-empty list. And looks like the non-empty list test happens here, right? And the non-empty list test will jump to opcode 12 if it fails. So if it fails, we're going to go here to 12, and then we do the isNil. So that corresponds to going here. So what's interesting is that isNil seems like it tests for empty list. So let's change that to this. And let's recompile. We're going to do the same operations again. And let's take a look. And lo and behold, we do have this isNil test. So the lesson of this video is that in Beam opcodes, the isNil test refers to whether or not something is the empty list. So the emptiness list clearly here is referred to as nil. A little bit unusual, a little bit unexpected if you come from Elixirland. But if you're in Elixirland and you want to go down into sort of low-level Erlang stuff, it's a good thing to know. All right, take care, everybody.